Why, hello. Tonight we're talking about, we originally titled our presentation something about a certain bank, something getting breached or something. Then we thought we should probably change that to just running with scissors in the cloud. Because I don't know if you read the headlines today, but the next data breach could really probably be just about anybody. So we thought we would be nice to them because we heard they actually do security pretty well in Amazon. But anyways, I just want to introduce ourselves. Start off, my name is Tom Pohl. I'm actually head of architecture at Business Solver, and then I'll let Mr. Brad Williams introduce himself, and we'll get underway.
Yeah, I'm Brad Williams. Apparently, I'm a cloud engineer. I wear a lot of hats at Business Solver. Okay, so I know we have a lot of different experience levels out there, so I just want to go through some basics. By the way, I hope you guys like cat memes, because apparently Tom really likes cat memes. We have a lot of them. Okay, what is AWS? From Wikipedia, Amazon Web Services, AWS is a subsidiary of Amazon that provides on-demand cloud computing platforms to various things. On a metered pay-as-you-go basis. It's the cloud. They're the #1 cloud provider. Azure and Google Cloud Platform are the other, a couple other big players. So a couple of things we'll be talking about, and these specifically are about AWS, but there are similar concepts in the other cloud providers too. First of all, there's VPC, which is a virtual private cloud. It's essentially your logical data center in AWS. You have your networking, you put your instances or VMs in there, and it's logically separated from everything else. EC2, Elastic Cloud Compute, you run your instances. If you're familiar with VMware, they're your VMs. They're your servers in the cloud. S3 is your object storage. Runs probably, 80% of the internet. They're organized into things called buckets. And then we have IAM, which is Identity Access Management. It's how AWS provisions access. All right, so Tom, I don't know if you want to talk briefly about what we're actually, what happened to prompt this talk.
Yeah, so the problem is that anytime that you're doing things in the cloud, it's somebody else's computer, but it's on you. It's you're running infrastructure in somebody else's data center, and you can do things the right way and you can do things the wrong way. And the difference between the two, a lot of times, is very little. It's like sometimes it's just check marking a box, and then all of a sudden you go from having a secure service to an insecure service. And we wanted to look at a particular instance of how you can misconfigure where they did a lot of things really well. In the case of the Capital One data breach, as far as we're aware, we've talked to a lot of people that have a lot of access to a lot of different things, and it sounds like they didn't have the biggest thing that we see in a lot of the recent data breaches is public S3 buckets where the data was just sitting out there for anybody to download. That wasn't a thing. Is the data encrypted in the cloud? Their data was likely encrypted in the cloud at rest, right? Because you always hear well, it's encrypted, it's secure then, right? Guess what? Undoubtedly, their data was encrypted in the cloud. Was their software up to date, or were they down level on patching? All points showed that everything was patched and everything was up to date. And only things exposed to the internet were things that they wanted to be exposed to the internet from a networking perspective. They had a web server, and they wanted that web server to respond to web requests, and it did. And so, a lot of the things that they did really, really well, but there was, a critical flaw or that ended up causing a major issue.
Yeah, I have 4 AWS certifications, including I did the beta security exam. So supposedly I know something about cloud security. A lot of these things are best practices, and I think they did a lot of these things, and it didn't help them. A lot of what they teach for best practices didn't really help in this situation. So what was the problem? The problem there's an EC2 feature called instance metadata, and you can exploit that with an attack known as a SSRF, server-side request forgery. Go ahead.
So with the server-side request forgery, basically the way that this issue works is that, and we'll get into it because this is not a new issue. So we found a tool put out by Rhino Security Labs. I don't know anything about Rhino Security other than checking out their tool. They actually released it in July of 2018, and they've got like 6 scenarios that you can actually go and deploy these 6 scenarios, and they're vulnerable as heck. And one of their 6 scenarios is, they call it Cloud Breach S3, Cloud Goat scenario. And this, from everything that we've read and researched and looked at, looks exactly the way that, or pretty close to the way that Capital One got breached.
Yeah.
Go ahead.
There was even an article 2 years ago from 2017 that basically detailed out this exact scenario.
Yeah, so what it is typically in a web-based architecture, and we'll go through it. We'll actually have a live demo here, so a lot of this stuff you won't be able to read real well because it's kind of small on the screen. But in a web architecture, you'll have up front, you'll have like reverse proxy servers or a web application firewall that then goes in front of your web application servers that then may front talking to other services on Amazon like S3 buckets and things of that nature. And in this scenario, they were able to basically get at a service that, so every time you spin up a virtual machine in Amazon, there's a secret kind of a web, or not really a secret, but there's a web server that's available to every instance called the metadata service. And it's got a special web address called, it's non-routable on the internet. Are you guys familiar with non-routable IPs? It starts with 169.254. 169.254 is the website. Like, if you know anything about routing, like that's not like if you don't get an IP address when you put yourself on a network, your computer will automatically find an IP in that range to give you because it's like, I can't find an IP. Let me just come up with one for you. And so this is one of at that address in all these cloud providers. It gives you information, and that information can lead to severe compromise depending on what roles and what attributes you've given your instance, and that's exactly what's happened here. So to tell you what we've done is we've set up our own environment that mimics kind of the same way. So we spun up an Nginx a reverse proxy server that sits in front of a web server, but what we did is we attached what's called an IAM role or an identity access management role to that instance that has access to an S3 bucket. And so since we made the same misconfiguration to the Nginx proxy, which was actually really easy to do, we were able to make it so that from an outside perspective, we could come and make queries against this identity access management server and give us credentials, like legit credentials that we can then go take and log in, not going through their servers, and get access to all the data that account or that IAM role has access to on Amazon Web Services.
Because S3 is public, even though you're like blocking public access. That doesn't actually block public. You can still access it publicly. You'll get access denied, but if you have the correct credentials, you're going to be able to access that. Yeah, filtering.
So the credentials that you have access to, those aren't limited by IP range, VPC, or anything. So if you've got legit access tokens to S3, they work from anyone's computer, and we'll show that later. So the proxy server, so in a regular web architecture, your proxy server, your reverse proxy that kind of sits up in front of all your web application servers should be configured that the only thing that they're allowed to talk to are your web application servers and nothing else. And so that's the trick, right? That's the crux of the issue, is that if I can convince your web proxy server, which in the case of the Capital One breach, it sounded like it was their web application firewall, which is typically a piece of software that looks for bad requests and says, oh, that's a bad request, I'm not going to serve that up. They didn't take into consideration the metadata service URL. and someone was able to convince their proxy server to gain access to that information server, and the layer on top of that, they had attached a profile to the web application firewall that had access to read S3 buckets. So they over provisioned access for that web application firewall server, and then they could go and download all the data, and that's what appears to have happened in that case. Sorry, we just put the slide together like late this afternoon, so we didn't even practice this. But when we the attack that we'll show you how you can hit a proxy server and say, hey, can you go talk to a thing that you're not supposed to talk to? And there's actually other people that have gone out there and done research. Apparently right now today in Amazon, there's about 800 websites that currently are misconfigured the same way that Capital One is configured today, which is kind of terrible because you don't know what level of introspection. And not only that, on the web data, on the metadata service URL, if you ever spin up an instance and you give it like, hey, when you start up in life, like I want to give you credentials to a thing, or I want to set default passwords, or I want to tell you some secrets so that my AMI instance or the hard drive that spins up in the cloud doesn't have any credentials. I'll give them to you when you spin up. You'll a lot of times introduce that, or a lot of people will introduce that. I don't introduce it through the metadata service, so that you can get that. Some people will introduce keys into their instances that way, so that when they spin up, they'll have access to go talk to database servers or decrypt things or have access to stuff. And we'll show you how to craft a request against that proxy server so that we can go do bad things. And like I said, so in this case, and I'll show you how we actually created a WAF role and attached it to our Nginx reverse proxy, and then gain access to the credentials. And here, we should just skip ahead. Go ahead.
Let's just do it. Yeah. I think. Oops.
No, you've done it. So here, let's just go live, right? Like, who here was at DEF CON this week and went to closing ceremonies? One guy. What did the Dark Tangent say? What did the Dark Tangent say when they started having technical difficulties? No, they said, "Fuck it, let's do it live."
That was two.
Oh, was that two? I apologize. Did we just exceed our PG-13 rating?
I think mine was half.
Sorry. No nudity. I'm keeping my clothes on. So just to show you what we did. So I created this website called capitalbank.tompohl.com. So it's the welcome to the super secure bank. Please log in to continue. And it's like, okay, that's really cool. It's not even HTTPS, but it's totally cool. And so what we can do, and I don't know if you guys ever do things from the command line. Here, now, let me make my screen really big. Okay. Tell me can you read that now?
Bigger? We good?
It's good? All right. So what we're going to do here is I like to telnet to servers and make web requests manually. So if you've never done this, so if you go it's not that hard. So you telnet to port 80 and you'll get like a connection. I'll say get/http/1.0 and be like, okay, sweet. There's the super secure website right there. But then what if we said, hey, let's get after, and this is where we're trying to get after the metadata URL. So we'll say, let's go after http://169.254.169.254 / its latest, right, / http/1.0, right? And we'll be like, oh, look, there's dynamic and metadata and user data. That means I just got some data from their service that I wasn't supposed to probably get after. And go ahead.
I would just stop you right. So metadata, there's going to be, and Tom will show you, there's going to be a lot of different categories of metadata. User data is you attach, and oftentimes this is like base 64 encoded bash script to bootstrap your instances. And I think, Tom, didn't you Can you bootstrap this one with something?
Hells yeah.
Okay.
So now that we know, like we telnetted to it and we grab this latest URL and we say show us it's giving us back information that we probably shouldn't be getting.
This isn't part of the breach inspired talk, but this is just another thing that could happen.
That's true. So we can pipe this in the curl. So I'm going to use a tool called curl. Yeah, you could also use the notorious hacker tool called wget, but I'm going to use curl this time. And what I'm going to do is I'm going to say, hey, I'm going to use that capitalbank.tompohl.com like a proxy server. And I legit said, hey, it's a proxy server. Just treat it like a proxy server. And then I said, I'm going to go after this URL, 169.254, 169.254, and go after the latest metadata URL service or directory. And then you can see I've got that I get basically the same thing back that I got before. Here, let me do and echo. So that then you can see there's 3 directories that come back: dynamic, metadata, and user data. Ooh, what's the user data? What do you think could be in there? User data? Oh, it echoes, this is a terrible password in the password command and sets it as the root password. This has actually been found in the wild. Like people will set the root password on an instance by setting up user data to actually set the password on launch of a virtual machine. So this is like in this we didn't make it actually do that here because that would be terrible. But
it's not a bad pass.
It's not a bad pass.
32 characters.
Yeah,
special characters. Yeah.
So if we let's go after metadata, because this is the one that everybody's interested in, right? So under metadata, there's all sorts of information. There's AMI ID, and there's events, and host name, and identity credentials, and IAM, and instance IDs. Like we can see, like, where is this thing running in the world? Like, let's go find. What kind of instance type is this? Is this thing running with a ton of GPUs and lots of RAM? No, it's a T2 micro. So I guess we're not going to go a whole lot against it. But like this is all stuff that me as an attacker, I'm on the unauthenticated. Like anybody right now, you could be playing and doing this at home right now because it's completely open to the internet. And I invite you to because this is kind of fun. We haven't showed you the credentials. You can go get your own credentials right now. I mean. So, but of all these IDs, the one that we want to focus in on is IAM. So this is the identity access management.
Bonus points if someone tweets out the
yeah, give us give us the token before, or the identity secret before we get to it, and you get a prize. I don't know what. Probably a high five, maybe a free drink. You want to do a shot? All right. So under here, there's a couple of different things. There's info, which is it can give you some access to some profile IDs and the name of the role. So you can see that this ISRM WAF role is actually attached to this instance. And actually, let me roll over and show you just how easy this is to attach an instance. So if we go to the Amazon console, I think I'm logged in. If not, I'll log in for you. Okay, yeah, make it bigger there. So in here, EC2, so this is how you launch virtual machines. And in the virtual machine, actually I
launched them with
Terraform. Funny man here. This is not the way if you do Amazon stuff legitimately a lot, you actually don't launch things this way. This is a very manual way. But under instance settings, and this might be terrible because there we go. And so you can attach or replace your IAM role. So basically what we did here is we created what's called an identity access management role, and we attached it to the instance. And so we can actually, if we wanted to, I can show you where that's at, where we type in role and we say IAM, and it's so easy that when you create a role, to come in here, they'll even tell you, hey, here's what it's all about. You can give your EC2 instance access to all sorts of different services on Amazon. And you're like, oh, cool, let's do that. And so we actually added Amazon S3 read-only access. I could have granted full access. I could have done Redshift. I could have done any number of 555 different roles could be associated. That, if I create that as a role here, then instantly when I say go back to the console and say map that role that I created, which is any number of these 555 different policies, that now instantly that virtual machine has the role rights on Amazon that I just gave it. And so
we don't know if it's actually S3 read. It could have been something else, and they just did some privilege escalation.
yeah, exactly. And another thing you can do, you can actually
This is the simplest way.
Yeah, this is the simplest way, and we like simple. And so, and what's great is that now that we can see that those credentials are there, we can actually query and say, oh yeah, the ISRM WAF role is actually mapped to that instance. And so then now if I actually go to that unauthenticated, this completely unauthenticated, and I grab that WAF role, guess what I get? Security credentials. That got me an access key and a secret access key, and then this token. And so, and so,
He really likes.
I really love cat memes, not gonna lie. So now, if I go into my credential store for AWS, which I don't know which
So you got Joe installed.
I got Joe installed, yeah. So I don't know what credentials I've got in here, but we can
Hope someone
replace.
screenshotted that.
Yeah, if you can screenshot these, that'd be great. I mean, these won't last longer than 5 minutes after our talk. They'll be gone. But so you got 5 minutes. Get after it, man. Spin up as much as you can with your read-only access to my S3 buckets. So what I'm doing here is there's a command line interface to all of Amazon. So Amazon's done really cool things. They've made things so that you don't have to go to a web interface to launch instances, to upload stuff, or even call functions. They give you command line tools or other APIs in order to do all these functions. And so what I'm doing is I'm just setting up in a configuration file, I'm taking all that information that I got back from that unauthenticated service, and I'm setting it up so that now on my Mac, see nobody special in my AWS directory, I can say AWS, and I can say S3 API, and I can say list buckets, right? And so what this will do, it'll say, ooh, if I don't have access, it'll be like, sorry, access denied. You don't have, with the credentials I just provided, it'll be like, you don't have access to do anything. But it came back and says, oh yeah, you got a bucket. You got a bucket right here called ICANN has data. And so then we can come back and be like, really, ICANN has data? Well, can I list that bucket? And be like, oh yeah, there's data in here. And so this is essentially how we believe that the Capital One data breach occurred, right? So somebody hit an unauthenticated service, got credentials. With those credentials, now I can go directly after an S3 bucket. This S3 bucket's a private bucket. Nobody can do this unless they've got access to the bucket, because completely private. Only people with authenticated credentials can have access to it.
This is also completely encrypted. All this data is encrypted.
Oh, that's right. Oh, yeah, I grabbed the command. So this data must be completely secure, right? Because wait for it. It's encrypted. This is encrypted data. So there's no way I can have access to this data. But here's the problem with encrypted data in the cloud. It's only encrypted to people that don't have access. I've got access. So it doesn't matter. This is AES 256 encrypted, as good as it gets, right? In today's standards. So that must mean that it's completely secure and I can't do anything with it until I go ahead and sync that bucket with my subdirectory here. Look at that. I'm downloading to my laptop data from the ICANN has data bucket directly onto my laptop. And what's in there? Oh yeah, cat pictures. Yeah, that's what I'm talking about. Got all the cat pictures in there. ICANN has passwords now. So whatever's in that bucket, I have access to. And I did this directly. So my only call in the only things that I did directly against that S3 or that EC2 instance was make that call to get the credentials. Now it's just a conversation between me and Amazon directly. So if you don't have things like CloudTrail enabled or other logging against your buckets, you're not even going to see me exfiltrate the data off of Amazon. So that's why it's super important to make sure that you're monitoring all the things. And when you're in the cloud like this, you've got to understand. And I always say this to my guys: tell me if I'm wrong. Whenever we ever employ a technology, we have to own and understand it deeply, right?
That's right, Tom.
Every time. Because if we don't, you can easily misconfigure a thing and all of a sudden you've lost all your data. because it's no longer, like in your data center where it's a walled garden approach, right? Where it's like there are no walls anymore. The walls are down, and everything has to be as secure as or nothing is secure. So let's go.
And honestly, I mean, it just feels like something that there's a bunch of different teams working on, and they just didn't communicate what each team was doing. So nobody ever put the picture together completely.
More data. What's that?
Nobody put the cat picture together.
Yeah, that's right. Yeah, so here we explained, Mittens the Destroyer wears the heads of his enemies, because what happened? It was encrypted data, but it's not encrypted data because we had access keys, right? All right, so how do we prevent this, Brad? What do we do, Brad?
There's a few things. Obviously, when IAM rules using least privilege, I don't know why the server that was exploited had the credentials it did. It probably had too much power. So being really careful when you're creating IAM rules, reviewing those and understanding. Don't just do EC2 star, EC3 star.
Who's responsible for this data breach? That's a loaded question, right? Is it Capital One? Is it Amazon? I think it's a shared responsibility personally. One of the things that in our research of this, there's a whole lot of workarounds. So this metadata service exists if you know about it or not. You don't have an option to turn this off. You don't have an option of securing it anyway. It's available to every instance that spins up. There's a lot of workarounds that people have done, like null routing that address from your virtual machine if you're smart enough to know that it exists. A lot of times, you may need it on boot of your instance, and then you never use it again. So if that's the case, why don't they give you an access to shut it down after you're done with it? Why don't they give you an option when you launch your instance to say, you know what, I don't need that metadata service. Let's not even make it available. And let alone, give, a URL that's got default credentials. Why don't you have it so that, like Google actually has started trying to make some progress towards securing their metadata URL. You actually, in order to make a request against it, you have to introduce an additional header into the HTTP request that will then, say, okay, it's not just an HTTP 1.0 request, it's also adding this other header that then says, okay, give them access to that data. But at the same time, what happened, in the case of open public S3 buckets, it used to be a checkmark box and your S3 bucket was public. Now it's almost an act of God when you go through there and create an S3 bucket to try to make it public, because they're like,
have that locked down.
yeah, because there's so much outcry.
But you don't need it to be public to access it.
Yeah, but if you've got other services like this, I think that's probably what's going to come out of this, is hopefully that Amazon will be like, okay, we need to do a little bit more in order to keep people from shooting themselves in the foot, with a misconfigured service. And so hopefully we see them do that more. Some of the other things that, like I said, you can do, you can firewall it off so that your instance itself can't get there. And then, at the bare minimum, you should make sure that you only give access, at the minimum level that you do. Should Capital One's web application firewall had access to S3? Maybe not. It's hard to say. I don't know anything about their infrastructure, and I didn't even hit it once. So
definitely shouldn't have allowed proxy to access instance metadata.
Exactly, and we understand, from a lot of research and talking to people in the industry, Capital One is an organization that does really well with cloud security, and so I think this is a topic that we can all learn, right? If you're not in the cloud today, you probably have people in the boardroom saying, "Why aren't you guys going to the cloud?" And when you do, because you probably will, if you haven't already, you need to, like I said, own and understand everything so deeply so that you can hopefully avoid loss prevention cat because he's watching you. Anyways, I want to say thanks. Do you have anything more to add, Brad?
I don't, but I'd love to hear questions.
Yeah, so right there.
This is more like inspired by the breach. We don't have the actual.
I mean,
technical-
I've heard everything from they were running a proxy called like 3Proxy to they're running mod security. I honestly don't know the hairy details. All I know is they had a web thing that was acting likely as a web application firewall that was allowing access to get at the metadata service URL. And so you can misconfigure. I think I saw a page out there. You can misconfigure Squid or Nginx or any number of fronting proxy services. And as long as you misconfigure it the right way, you can give access to anonymous people to your metadata service URL. And it used to be that unless you attached an IAM profile to it, you're not actually giving out keys. So they had to go through that extra layer of, hey, I'm going to do the right thing and introduce an identity access management profile to this EC2 instance to try to lock it down. But you don't know. Did they do that to try to lock it down, or were they trying to give it additional access? We don't know. If they hadn't attached a profile, I can tell you they wouldn't have been giving out keys. But since they had attached a profile, and that profile then was available, exposed through the metadata service, then anybody could get keys to it. And like I said, someone did some research and presented it at B-Sides in Texas about a month or two ago, and they did a scan of all Amazon IP space without trying very hard, because he just created an automated scanner. He found at least 800 servers on Amazon that have the same kind of an issue. And then and then in the user data, he found terrible things. Like what I showed you, echoing a password into change your password for the root account was not uncommon. That's a very common way that people have abused or I wouldn't even call that misconfiguration. It's just not following best practice, right? It works. If it works, you don't touch it, right?
This is a documented feature.
Any more questions? Yeah.
I mean, like you learn what instance metadata is. It isn't apparent how powerful it can be. This is not. Just talking to a lot of people that do cloud. This is just not something that. It's something that's really easy to skip when you're making considerations for how you secure data in the cloud.
And you can do a whole lot right and just get one thing wrong, and then you're owned, right? And this is why you got to be out there. If you guys aren't employing third parties or also red teams internally and trying to hack your own stuff, especially if you're in a public cloud environment, do so. Run, don't walk to the nearest pen tester and get them to hack your stuff. More questions? Yeah, bet in the back. I heard some of that, and that's where I think the numbers I've heard numbers go from 100 million to 106 million. I honestly don't know what was tokenized and what wasn't tokenized. I mean, obviously, what ultimately got reported is what we know. I mean, definitely, if you can, don't store sensitive data in places where they can get reached by stuff that shouldn't have access. But the problem is that what if you needed access? What if they were able to not just abuse the proxy server? What if they were able to abuse all the way down to the application server? Maybe the application server had access, and the application server should have access to the data. And I think in this instance, most of the things that I had heard that were like applications for credit cards. What do they ask for when you apply for a credit card? And if it's all that kind of information, it's everything in the kitchen sink, your social security number, your date of birth, your address, all the things in order to cause you havoc if a bad guy got a hold of it. More questions? All right. Well, thank you guys very much. This has been fun. If you have questions and you want to reach out to us, Brad is XBCW9 on Twitter, and I'm very creatively Tom Pohl on Twitter. I'm the notorious hacker known as Tom Pohl, apparently. I think I was called out by Dark Tangent one time several years ago in front of 26,000 hackers, saying that I'm the only guy that goes to a hacker conference and uses his real name. But so if you want to reach out, you can find us on Twitter. I'm creatively Tom Pohl anywhere you look for Tom Pohl, except there's another Tom Pohl. It's a hockey player. That guy's not me. So anyways, thank you very much and have a good evening.
Thank you.